guys, today I'm going to be doing the GPS video, well, a GPS video. This one is going to be over the test, which I'm in the Tuesday, Thursday class for Emberton, and the test is tomorrow, or Thursday. So I'm just going to give you some of the key things I think you need to know to help with the test, and I might even specify which ones that I will be writing down on my note card, just in case you need that little bit of help. I say will be because I haven't wrote my note card yet, even though the test is tomorrow. I have a print off of the study guide he gave us, which can be located on Blackboard. Let me just switch over. Boom. We'll just go through these and we'll start with number 1. All right, so number 1 says the elements in the same column will have similar or different characteristics and why. So what it's asking you is when you're looking at the periodic table, the columns, or why will the columns have different or similar characteristics with other elements in the same column? Well, why would elements have similar or different characteristics with elements in the same column? Which he didn't talk a whole lot about that when we were going over the study guide, so I don't feel like that's going to be like a major part of the test. But basically just like about noble gases and metals and non-metals, what you need to know about that stuff. Okay, you need to know what a compound is. In the notes he gave us, a compound is recorded 2 or more elements combined together in a fixed ratio. You also need to know which of these categories have the most elements. And metal is the answer to that. So on number 3, which has the most elements? Metal is going to be your answer. Know where these columns are on the periodic table. Halogens, noble gases, and alkali metals. If you look right here at this periodic example, it shows alkali metals is this blue section right here. Alkaline earths, this red section. Transition metals, which is this purple section. Halogens is this green section right here next to your noble gases, which is the yellow right here. And I'm going to switch back over. Sorry if this is making you a bit dizzy. Okay, so you need to know the names of the columns on the periodic table. I just showed you the periodic table, and those are the names of the columns you'll be using. It says know how temperature affects the solubility of gases and solids. With solids, as the temperature rises, so does the solubility, and with gases, as the temperature rises, the solubility decreases. Examples of physical and chemical change. Physical change is when the surface or the way something looks changes, like you would think. And chemical change is more when like the compounds or the things inside of, like the things that make up something change. But you can look up some different examples of that. It says, how does activity increase across the periodic table for the metals and non-metals? The answer he gave us for that was cesium is the most reactive metal and fluorine is the most reactive non-metal. Cesium, I don't know if I'm spelled it right, but I'm pretty sure I'm saying it right based off of what he said. So cesium is the most reactive metal and fluorine is the most reactive non-metal. Know what a polar molecule is? You can just Google that and it comes up with the same correct answer if you don't have it. What happens to an electrolyte when it dissolves? Well, it dissociates, so it breaks down into ionic compounds or ions. It breaks down into ions. What is the pH of distilled H2O, which is 7, because H2O is, when it's distilled, is a neutral substance. You need to know the temperature rule of thumb, which says typically an increase in temperature increases the reaction rate. What cannot be decomposed? by chemical means, that's going to be its element. Because like the elements on your chart, those are what you start with to make compound molecule. It can't be broken down farther than that. Well, by chemical means, at least. Know what a saturated and unsaturated substance is. A saturated substance is when all the solute that will dissolve at that temperature has been dissolved in that solution. And unsaturated is when not all the solute that will dissolve at that temperature has been dissolved into the solution. 21 says, remember, like dissolves like, which is basically the example I gave you last week, where water is polar and will only wipe things off your hands easily with other polar molecules. Like an oil is non-polar, and that's why water will not wash oil off your hands. So polar to polar to polar, non-polar to non-polar. What is dissociation? Dissociation is also called ionization, something like that. And it is when a compound breaks apart into ions. What is an acid and what is a base? The way to sort that out on what is an acid and what is a base is an acid is H plus and a base is OH minus. So where is that at? Plus. What 100% disassociates in solution? And that would be a electrolyte. Or what it's asking is if it's a strong or a weak electrolyte. It's a strong one if it 100% disassociates. Acids, basic, and neutral solutions are what pH? Acidic solutions are going to be 1 to 6. Neutral is 7. And then from 8 to 14 is going to be basic. 14 is like the most basic, and 1 is the most acidic, and 7 is the middle number. So that's a good way to remember that. What is necessary for combustion or burning? You must have fuel and oxygen for combustion. And the only products of combustion are CO2 and water. Endothermic and exothermic means what? Endothermic means take in, is to take in heat, and exothermic is to release heat. It also says, my notes also say, and it's not on there, but it says catalysts increase rate of reaction, but are not used up in the chemical process, which is something you need to know. And also, increased surface area increases the reaction rate. Now, this last thing right here on the bottom says, know how to draw an atom of an element using a Bohr diagram. And then it says, all circles I drew. So, what we're going to do, we're going to use aluminum on a graph. Let's pull that up again so I can show you. It's right here. I know you can't read it very well, but it has 13 as its number thing. You can tell because it's the one right above the letters. That's the one you're going to go off of when you're drawing this. So if that says 13, then that means there are 13 protons in your diagram. So you're going to make an A and an L. That way you know what element you're talking about. And then we're going to stick 13 right here, so you know how many protons are going to be in it. Okay, then you'll make your first circle. For every proton, you have to have at least you have to have one electron. But you can only put so many electrons in each circle. So in your first circle, you're only allowed 2. In your second circle, you're allowed 8. But you still need 3 more, so you're going to draw your third circle, which gives you 13 electrons to 1 electron for every proton. And that is how you draw a Bohr's diagram. You'll need another for the test, obviously, or I wouldn't have showed you. And that's actually all I have left for you today. So good luck on your test. Don't forget that you can use a note card, and that will help you out an awful lot on your test. If you haven't been getting very good grades, then now's your time to shine. It's now or never. Don't worry too much about it if you have one bad grade, because he drops the lowest test score. So that will help us out. Just keep it up, do your homework, do your labs, all that good jazz, and try your best on the test. If you put some of these notes that you can't remember on your test, on your note card for your test, it's going to make it a heck of a lot easier on you. My name is Sarah Spurlock. I work in the Native American Center here on the 3rd floor of the OSU building in room 1318. If you need any extra help, just come by and visit me, or any of my colleagues would be willing to help you. Thank you guys. Have a nice night.